Welcome back. The objective of this video is to introduce the trigonometric identities and do some samples with some of those identities. Here's a summary of some of the fundamental trigonometric identities. There are reciprocal identities. We know that the sine of theta and its reciprocal is cosecant, so the sine of theta equals 1 over the cosecant. And the cosecant of theta equals 1 over the sine. They're reciprocals of each other. And that's the same for cosine. Cosine of theta is 1 over the secant, and the secant of theta is 1 over the cosine, and tangent is 1 over the cotangent, and cotangent is 1 over the tangent. So those are reciprocal identities. Our quotient identities, we've seen this already. The tangent of theta is sine over cosine, and cotangent is cosine divided by sine. And then there are the Pythagorean identities. In the past, we've seen the sine squared theta plus cosine squared theta equals 1. That one we're familiar with, or should be. And keep in mind here that sine squared theta is we're squaring the value of the sine of theta. We're squaring the value of the cosine of theta. We are not squaring the angle. But the sine squared theta plus cosine squared theta equals 1. Another Pythagorean identity, 1 plus the tangent squared of theta equals the secant squared of theta. And we can prove that to you by doing a little simple rewriting. 1 plus tangent, we know tangent is, using our identity above, tangent squared is sine squared over cosine squared theta equals secant squared theta, and the secant squared theta is the same as 1 over the cosine squared theta. So simply rewriting that into this form, it looks like that. Now, if we multiply everything by our denominator by cosine squared theta, we get cosine squared theta plus sine squared theta equals 1. So these two identities are equivalent. And we can do the same thing with the third Pythagorean identity, 1 plus cotangent squared theta equals cosecant squared theta. Rewriting this, this can become 1 plus cosine squared theta over sine squared theta, that's our cotangent, equals the cosecant squared theta, which is the same as 1 over sine squared theta. And in a similar fashion, just like we did on the previous identity, now we can multiply all this by sine squared theta, and that leaves us with sine squared theta plus cosine squared theta equals 1. So that checks out that this third identity is the equivalent of our Pythagorean identity. So all three of those are Pythagorean identities. Doing a sample problem, I forgot the cosine here. The cosine of theta is 0.96. Find the values of a and b using the trigonometric identities. Well, on the first one here, the sine of theta, we're going to use sine squared theta plus cosine squared theta equals 1. We'll use our standard Pythagorean identity. Sine squared theta plus, well, we have cosine. They gave it to us. It's 0.96. So 9600 squared equals 1. Subtracting the 9600 squared from both sides leaves us with sine squared theta equals 1 minus our 9600th squared. We take the square root of both sides, and we get the sine of theta equals the square root of 1 minus 0.96 squared. We can go to our calculator. Square root of 1 minus 0.96 squared and that gives us our answer of 0.28. In sample B, the tangent of theta. So we want to find the tangent of theta. All we have is the cosine. So I'm going to use the trig identity of 1 plus tangent squared theta equals secant squared theta, because secant is the reciprocal of cosine. So 1 plus tangent squared theta equals 1 over the cosine squared theta. These are equivalent, and I have my cosine squared theta, so it's 1 over 0.96 squared. Subtracting 1 from both sides, I get the tangent squared theta equals 1 over 0.96 squared minus 1. I want to find tangent, not tangent squared, so I have to take the square root of both sides. So the tangent of theta equals the square root of 1 over 0.96 squared minus 1. So I carefully put all that into my calculator. Notice I use parentheses here for my 1 over 0.96 squared minus 1. Make sure that's all under the square root, and I hit enter, and I get my answer of 0.2916 repeating. Sample 2, let theta be an acute angle such that the sine of theta equals 1 over 4. I know my opposite is 1, my hypotenuse is 4, or my y is 1, and my r is 4. Find the values of a and b using trigonometric identities. So the cosecant of theta, well, that is 1 over the sine of theta. And I have the sine of theta. So the cosecant theta equals 1 over the sine, which is 1 over 1/4. So my cosecant of theta is 4. Then they ask us to find the cotangent of theta. So I have a Pythagorean identity that involves the cotangent. So I'm going to grab that. That's 1 plus the cotangent squared of theta equals the cosecant squared of theta. I have sine, but I also have the cosecant that I got from my previous problem. So I have 1 plus cotangent squared theta equals 4 squared, because cosecant is 4, so cosecant squared is 4 squared. So I can subtract my 1 from both sides. I get the cotangent squared theta equals 16 minus 1. Take the square root of both sides to get the cotangent. And the cotangent of theta equals the square root of 15. Sample 3, verify that the cotangent squared theta equals 1 over the sine squared theta minus 1. So this is similar to what we saw earlier in the video. Cotangent is just cosine over sine. So cotangent squared, I can rewrite that as cosine squared theta all over sine squared theta. And that is equal to 1 over sine squared theta minus 1. I have sine squared in my denominator. I can multiply both sides. So I multiply everything by sine squared theta. So my sine squared thetas cancel. And I get cosine squared theta equals 1 minus sine squared theta. Add sine squared theta to both sides, and I get the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. So I verified that this is a true statement because it leads us to the Pythagorean identity which we know is true. And we'll get some more practice with working with these identities when I see you in class.